All right, this is a video lesson for U2L8, which is comparing functions. This is a callback to many of the previous lessons in the unit, as we're going to be able to, or need to be able to understand multiple representations of functions, many of the things with function notation, and then the new concepts of being able to compare two functions using these skills. So the first problem is going to ask us to do something with k. This is the k function here. If we read the problem, it's at Kuiper's family farm and Gobbert's pumpkin patch. You can pick your own apples. The pricing is different at each place. The representations below show the cost of picking X pounds of apples. So we've got our Kuiper's function and our Gobbert's function. So they ask us the value of k of 1.5. So I'm going to go, 1.5 is in parentheses, so that's an input. So I'm going to go to 1.5 on the x-axis and figure out what the y value is, which is 3.5. So k of 1.5 equals 3.5. And what this says is 1.5 pounds of apples at Kuiper's costs $3.50. We're just explaining the meaning of the problem. Now they ask us which is bigger, k of 2 or g of 2? Well, this is a good comparison because it's telling us an input of 2 means pounds of apples. So we're going to find out the cost of apples at Kuiper's and the cost of 2 pounds of apples at Gobbert's. So at Kuiper's, we just use the graph, and it tells us that it's $4. $4 for 2 pounds. So k of 2 equals $4. G of 2, we're going to look at the x's and find 2, and the y with it is 3. So G of 2 equals $3. Well, which one's greater? The bigger output is 4. So that's the greater. And what does this mean? It means it costs more, because the output's bigger, it costs more for 2 pounds of apples at Kuiper's compared to Gobbert's. C, for what value of k of x for what value of x is k of x and g of x equal to each other? So this one's a little bit challenging. You're going to have to look around and figure it out. But we're looking, when are the two prices the same? So right here, I'm looking and seeing, I don't know, 3 pounds costs $5 here. What are we here? 3 pounds costs $4.50. Well, this is going up by about $1 a pound, it looks like. And this is going up by 75 cents. So let's keep playing around. 3.5 is $5.50. No, 4 is 6, and that actually matches 4 and 6. So that's the one, and I just had to play around. I had to see when they ended up matching each other, and it took a few guesses. But 4 and 6 seems to be the one. So k of x equals g of x when x equals 6, or sorry, when x equals 4, both outputs are 6. And the explanation in the context of the problem, we can shrink this down so we have room to talk about it. The explanation is it costs the same at both places for 4 pounds of apples. Both places, it's going to cost $6 for 4 apples. Now it asks us, which farm would you rather go in order to pick apples? Justify your reasoning. Well, here's something that I think would really help. to be able to visualize this and understand it. I'm going to take these G values over here, and I'm going to plot them on this graph. So half a pound, 75 cents. That's right there. 1 pound, $1.50. Pound or 2 pounds, $3. So I'm skipping around a little bit. 3 pounds, $4.50. 3.5 or 4 pounds, $6. They kind of match up at that point. 4.5 pounds, $6.75. And I'm starting to see what this graph looks like in comparison. And what you'll notice is that K, this is K, and this is G. K is above G in all these places. Like K, the line K is above the G line all the way until this spot where they cross each other. Then it looks like up here, you see the blue lines on top of the black line. So to me, it's all going to depend on how many apples you want. If you want less than 4 apples, it makes sense to go to G, Gobert's, because it costs less. All those outputs are lower than the Kuiper's outputs. But if you want a lot of apples, more than 4 pounds, it looks like G is actually greater and more expensive, so it's better to go to Kuiper's. So what you would say here is if you want less than 4 pounds, go to Gobert's. Otherwise, go to Kuiper's. And now we'll move on to number 2. This is going to have us do some comparisons. So they want us to compare f of 1 to g of 1. Well, for g of 1, I'm just going to have to plug it in. G of 1 is negative 7 times 1 plus 18, which if you use your calculator, tells us that g of 1 is positive 11. Well, f of 1 is only 0. So this is 0 and this is 11. 11's greater, so we're going to use the term is less than, because 0 is less than 11. Now g of 1 we said was 11. H of 1 is only 3. So now we're going to say is greater than h of 1. They ask us now in 3, which is a new problem, for what values does k of x equal p of x? Or for what value of x? Okay, well, for 2 and negative 9, these don't match. So it's not 2. 4 goes with 2 here, and 4 goes with 2 here, so that's a match. 6, well, I don't know anything about 6 according to p of x, so not that. And 8, I don't know anything about 8 according to p of x, so that doesn't work, and same thing over here. So the value of x for which k of x, h of x meets, k of x equals p of x would be the value of x4. Because in both cases, they produce an output of 2. Now for this one, it might be a little challenging to see, and this is another case where I would just graph this. Let's put these z values on the graph. 4, 2, well, that's not a match. The points would be on top of each other if this was a match. W of x is a graph. Z of x is a list of ordered pairs. So it's not 4, 2. Negative 3, 8. Negative 3, 8. That's like all the way up here. That's nowhere near that graph. That doesn't work. Negative 5, negative 4. Boom. That's an exact match. So that means that there's an input-output of negative 5, negative 4 in Z, and there's also an input-output negative 5, negative 4 on W. So that works. 2, negative 9, nope, it's way off the graph. So that doesn't work. So the value of x that does this is -5. When x equals -5, we're getting a match. Both w's point and z's listed ordered pair both have the same output when x is -5. Now we've got one more thing to look at, and then we'll be done with this lesson. Ali and David work at a water park and have to drain the water at the end of each month for the ride they supervise. Each uses a pump to remove water from the small pool at the bottom of their ride. The graph below represents the amount of water in Ali's pool, A of x, and David's pool, D of x, over time. They want us to list some observations that we see. Okay? Well, the first thing I'm noticing is that they hit each other. And they hit each other at what looks like about 10 minutes and maybe 14,000 gallons of water in both. So this is my first observation, after 10 minutes, both pools have 14,000 gallons. That's something they have in common. Okay? Now, before 10 minutes, I guess another observation I can make is that A, which is Ali's pool starts with 28,000 gallons. David's pool starts with 24,000 gallons. And it looks like over here, like Ali's pool has more water in it than David's, all the way up until that 10 minutes. Until 10 minutes, Ali always has more water. His graph's above David's graph. After 10 minutes, it's looking like David's graph has more. After 10 minutes, David has more water. Well, I think if Ali started, well, I guess here's two more observations. Ali's done after 20 minutes. After 20 minutes, you see he's got no more water left. He's down to 0. David takes 24 minutes. So you could ask who's draining faster. Well, if Ali started with more water and finished before David, I would say Ali is draining faster than David. And that's a ton of observations, and that covers pretty much every kind of question that could be asked based on that topic, and it's important for us to be able to look at a graph and make all these different kind of conclusions. And that's it. That's the end of comparing functions.